Dear students, under the lecture series on Laplace transforms, we are now solving problems under the results on Laplace transforms. So far we have completed till problem 12. Now this is a continuation video. In this video lecture, we will be solving problems by using the following trigonometric identities. That is, sine square t is equal to 1 minus cos 2t divided by 2. Cos square t is equal to 1 plus cos 2t divided by 2. And sine cube t is equal to 3 sine t minus sine 3t divided by 4. And cos cube t is equal to 3 cos t plus cos 3t divided by 4. So these are the trigonometric identities, and in this video lecture we will be using these trigonometric identities in order to solve the problems on results of Laplace transforms. So let us see them now. The first problem is problem 13. It is find L of sine squared t. So whenever we see such problem, that is, whenever we see problems to find the Laplace transform of the square of trigonometric functions like sine t or cos t, or cube of trigonometric functions like sine t or cos t, then we have to use the trigonometric identities that we have discussed just now. So for this problem, we have to find the Laplace transform of sine squared t. So the trigonometric identity for sine squared t is given by sine squared t is equal to 1 minus cos 2t divided by 2. So this identity we have to use now to solve this problem. So this Laplace transform of sine squared t can be written as equal to Laplace transform of the sine squared t can be replaced by using this identity. So it will be 1 minus cos 2t divided by 2. Now in the next step, we will use both the scalar property and linearity property in this function, that is Laplace transform of 1 minus cos 2t divided by 2. This 2 in the denominator can be taken out by using the scalar property. So it will be 1 by 2 of, now this 1 minus cos t, we can apply the L operator on each of the functions by using the linearity property. So it will be L of 1 first. So L of 1 minus L of cos 2t. So now in the next step, we already know that the value of L of s is equal to 1 by s. We have derived this result previously. So we can substitute that. So this will be 1 by 2 multiplied with 1 by s minus the result of Laplace transform of cos at is equal to s divided by s square plus a square. Now here we have L of cos 2t. So at the place of a, we are having the value 2. So the value of a is equal to 2. So the solution will be s divided by s square plus 2 square. And so that will be further equal to 1 by 2 of 1 by s minus s divided by s square plus 2 square is 4. And further, this will be equal to 1 by 2 of, we can take LCM over here. So it will be s multiplied with s squared plus 4. And so this will be multiplied with 1. It will be s square plus 4. And s will be multiplied with s. So we will be getting minus s squared. And so that will be equal to s square and negative s square will get cancelled. So 1 by 2 multiplied with 4 divided by s multiplied with s square plus 4. And this on simplification, we can cancel this and it will be 2. And so the final result will be 2 divided by s multiplied with s square plus 4. So this is the required solution. So now we will solve problem 14. Find L of sine squared 2t. We know the trigonometric formula for sine squared t. So sine squared t is equal to 1 minus cos 2t the whole divided by 2. So this is the trigonometric identity for sine squared t. But here we are having sine squared 2t. So in this identity, wherever we have t, we have to replace it by 2t. So when we replace t by 2t, what we get is sine squared 2t is equal to, so this t we have replaced as 2t. So that will be equal to 1 minus cos. Now 2, this 2 is already there. Now this t should be replaced as what? 2t. So 2t divided by 2. So therefore this sine squared 2t will be equal to 1 minus cos. So this 2 will be multiplied with this 2 and we get cos 4t divided by 2. So this is what we will be using here in the problem. So therefore L of sine squared 2t can be written as, so this will be equal to L of, now sine squared 2t can be replaced as 1 minus cos 4t divided by 2. Now next we can use the scalar property in order to take this 1 by 2 out. So it will be equal to 1 by 2 of, and then we will use the linearity property in order to take the Laplace transform to each of the functions. So this will be L of 1 minus L of cos 4t. So we have used both scalar property and linearity property as well. So these two we have used. Next we will be using the trigonometric, the result on Laplace transform, which is, we know that the Laplace transform of 1 is equal to 1 by s. And here we have cos at. So we will be using the Laplace transform of cos at, which is equal to s divided by s square plus a square. So let us solve now. So this will be further equal to 1 by 2 multiplied with, what is L of 1? It is equal to 1 by s. So 1 by s minus L of cos 4t. We know that L of cos at is equal to s divided by s square plus a square. Now here the value of a is 4. So it will be s divided by s square plus 4 square. So this will be equal to 1 by 2 multiplied with 1 by s minus s divided by s square plus, what is 4 square? 16. Next we shall take the LCM in order to simplify this. So it will be equal to 1 by 2 multiplied with, the LCM is s multiplied with s squared plus 16, and so now 1 will be multiplied with this. So it will be s squared plus 16 minus s multiplied with this s is s square, and so that will be further equal to 1 by 2 multiplied with this s square and minus s squared will get cancelled. So we will be left out with 16 divided by s multiplied with s square plus 16. So further we can simplify this by cancelling 2 and 16. 2 8 times is 16, and so therefore the solution will be 8 divided by s multiplied with s square plus 16. So this is the required solution. The next problem is, find the Laplace transform of cos square 3t. Now for this we should use the trigonometry identity cos square t, which is equal to 1 plus cos 2t divided by 2. So we know that the first identity that we will be using is, we know that cos square t is equal to 1 plus cos 2t divided by 2. Now here in the question we have to find cos square 3t. That is, instead of t we are having 3t. So wherever we have t in this identity, we have to replace it by 3t. So we will be getting cos squared 3t. So we have replaced t by 3t to be equal to 1 plus cos 2 multiplied with, so instead of t we have to replace it by 3t. So 3t divided by 2. So therefore cos squared 3t will be equal to 1 plus cos. Now 2 multiplied with 3 is 6. So 6t divided by 2. So we will be using this over here. So therefore Laplace transform of cos squared 3t can be written as, so this is equal to Laplace transform of cos squared 3t is equal to what? 1 plus cos 6t divided by 2. So 1 plus cos 6t divided by 2. The next step is we will use both the scalar property and linearity property. So that will be equal to, by using the scalar property, we can take this 2 in the denominator outside. So it will be 1 by 2. And by using the linearity property, this L operator can be taken to each of the functions separately. So Laplace transform of 1 plus Laplace transform of cos 6t. That is, we used both the scalar property and linearity property simultaneously. Next we will be using we know that Laplace transform of 1. So L of 1 is equal to 1 by S. This is the result in Laplace transform. And we need the result of Laplace transform of cos AT. And that is equal to S divided by S square plus A square. Now here this will be equal to 1 by 2. What is Laplace transform of 1? It is 1 by S. We will substitute that, plus Laplace transform of cos 6t. So cos 80 for result we have to use, which is S by S squared plus A square. But at the place of A we have 6 over here. So it will be S divided by S square plus 6 square. And so that will be equal to 1 by 2 multiplied with 1 by S plus S divided by S square plus 36. Now we shall take the LCM and simplify this. So it will be equal to 1 by 2 multiplied with, the LCM will be S multiplied with S squared plus 36. And now this will be multiplied with 1. So we will be getting S squared plus 36 and S multiplied with S, so plus S square. And so that will be equal to 1 by 2 of S square plus S square will be 2S square plus 36 divided by S multiplied with S square plus 36. Now in the numerator we can take the 2 common. So it will be 2 multiplied with S square plus 18 divided by, we do already have a 2 in the denominator, and then S, this S multiplied with S square plus 36. So that will be further equal to, this 2 and this 2 will get cancelled, and we will be having S square plus 18 divided by S multiplied with S square plus 36. So this is the required answer. In our next video, we will solve problems where we will be finding the Laplace transform of trigonometric functions when the cube is taken. That is terms like sine cube t, cos cube 3t, sine cube 2t. So we will be using the corresponding identity in order to solve that problem. So we will continue this lecture in our next video. Kindly follow the next lecture. Thank you.